Hello, everybody. I'm Joe Pryweller, Conference Director for Rubber and Plastics News. I want to welcome you to Rubber and Plastics News Ask the Expert series at the International Silicone Conference. This live stream series is your opportunity to engage with professionals on the current business environment and to interact with questions. Today's Ask the Expert is hosted by R.D. Abbott Company. Our speaker is Tom Jenkins, R.D. Abbott Executive Director of Business Development. Tom will provide a concise overview on optical and aging performance benefits of Dow Silicone's next generation moldable optical silicones. Your questions will be answered after the presentation. To submit a question, email rpnevents@crane.com, or if you're watching along on Rubber and Plastics News LinkedIn, Facebook, or YouTube sites, submit your questions through those platforms. With that, I will turn things over to Tom Jenkins. Tom, the floor is yours.
Thank you, Joe, and good Monday to everyone. My name is Tom Jenkins, and thank you for joining us. We're excited to participate in the International Silicone Conference virtual edition this year. We have a great topic, advances in optical silicone, so let's get started. Next, please. The LED lighting market is expected to exceed $125 billion in sales over the next 7 years. This is driven by the goal to decrease the total energy consumption for lighting by over 40% in the next decade. We have seen this change in our home lighting as we have progressed from incandescent to fluorescent and now LED lights. The many advantages of LED lighting include high efficiency, reliability, and high brightness. Today we'll focus on professional lighting or high-powered lighting applications such as stadium and street lighting and automotive lighting. Next, please. So our agenda will be the benefits of using silicone and LED lighting, moldable optical silicone products, the process and design benefits of silicone, and a few applications for optical silicone. Next, please. Conventional materials used for high-powered optics include glass, PMMA, and polycarbonate due to their high light transmittance properties. The newest material on the list is moldable optical silicone. Next. Highlighted are some of the properties where optical silicones excel in normal use. Exceptional light transmittance, similar to glass. High UV resistance, which means low yellowing in harsh environments. High service temperature, which means we can locate the optics closer to the LED source. Micro detail reproduction in the mold. Thick cross-section parts. Low weight compared to glass. And of course, the flexibility of silicone rubber. Next, please. Picture on the right shows the stability of optical silicone in harsh environments compared to polycarbonate and PMMA. All three lenses were subjected to sunlight UV, heat at 125 and 150 C, and the combination of heat and humidity. The optical clarity of the silicone lens was maintained under all conditions, while the thermoplastic materials undergo different levels of degradation, including yellowing and even melting. Under these typical use conditions, optical silicone material shows superior performance over thermoplastic materials. Next, please. So why choose moldable optical silicones? We've already discussed harsh environments, but also the ability to prevent ingress of particulate and fluids, as well as maintain high impact resistance. Extensive testing and certification to give you confidence to use these materials in applications that require UL recognition and automotive recognition. And then finally, a key factor is design flexibility, allowing the molding of undercuts and zero draft designs, excellent mold surface replication, which includes the transfer of fine microgroove detail from the mold to the part. And lastly, allows for multifunctional parts that enable fewer parts in the total assembly. Next, please. Dow has been a pioneer in moldable optical silicones for over a decade. The first generation product was the MS1000 series, and these products are widely used in the workhorses in the industry today. Based on customer and market feedback, Dow has further innovated these products. This next generation product line is the Solastic MS4000 series. These products offer higher light transmittance, especially in long light path applications, and higher hardness options with reduced surface tack, which enable tougher and more durable optics. Next, please. When Dow developed the 4000 product line, they wanted to improve the light transmittance and hardness without losing the advantages of the MS1000 series. Next. As we look at the comparison of physical properties, notice that viscosity is consistent across the product lines. So the materials process the same, and we can use common equipment through both product lines. Next. Differences occur in durometer. Notice the full durometer ranges from a soft and pliable 50 durometer to a hard and tough 84 durometer. MS4000 products almost feel like plastic, and the high durometer offers low tackiness as well as high impact and scratch resistance. The very high durometer material, the MS4002, provides very low tack, which also reduces surface and dirt and dust accumulation, leading to better optical performance in many outdoor applications. On the low durometer side, we have MS1003, which offers high elongation, which is perfect for parts that require high flexibility in the application. Next. Quickly, let's look at the optical properties of the MS1000 and 4000 series. Next. The refractive index and Abbott numbers stay very consistent across the product lines, meaning we can easily switch back and forth between products without affecting the optical performance of molded parts. Next. But if we look at the luminous transmittance data, we see that the MS4000 series has higher values, especially at higher part thicknesses. This is due directly to improvements in the chemistry sets of the MS4000 series. These improvements make the 4000 series more suitable for long light path applications. Next. A complementary material to the optically clear products are the white reflective products. MS2002 is the injection molding product, and ES3001 is the recently developed HCR product for extrusion. Applications include mixing chambers and remote phosphor designs. These highly reflective materials can increase optical efficiency and result in overall system improvement for light and color output. Next. Let's take a quick look at processing. Moldable optical silicones process like traditional LSR materials and are supplied in two parts for one-to-one mixing. So what's the difference? Traditional LSR materials use fillers such as silica for reinforcement, which result in translucent and sometimes hazy parts. Optical silicone materials use siloxane resins for reinforcement, allowing for the optical clarity. The chart below shows the difference in shear rates between standard LSR materials and the moldable optical silicones. We see standard shear rate for LSR. LSRs exhibit shear thinning in the injection molding process, where the moldable optical silicones experience minimal shear thinning. Moldable optical materials also start with a much lower viscosity, enabling them to fill the mold and replicate cavity detail easily. For molding simulation data files, Dow is working on the characterization files for both SigmaSoft and MoldX 3D. The MS1002 files are currently available. Bottom line, optical moldable silicones processed using the same equipment as traditional LSR materials for the injection molding process. Next, please. Let's look at a few applications. Our first example is a simplified adaptive drive beam lens. In application, this lens uses an LED light at the base of each light guide, and there are 12 in this example. The actual lens is far more complex, having many more light guides in the part design. This part geometry is difficult to impossible to manufacture from either glass or thermoplastic, but the design is achievable using optical silicones. The picture below shows a headlamp assembly manufactured by Hella, a leader in adaptive drive beam lighting. So how does this work? Most new cars have multiple sensors that can detect and in some cases identify objects in front of the vehicle. Using sensor feedback, these multi-segment adaptive drive beams can run with full-time high beams and turn off segments of light as to not blind oncoming traffic. This full-time illumination for nighttime driving is an important safety feature that helps the driver identify and ultimately avoid hazards. Next. Although a new product, the MS4007 has already won industry recognition in a sports lighting application, winning the R&D Top 100 award in 2019. In the application, MS4007 was used directly over a high-powered LED chip. The material was chosen for its design flexibility to handle this large, complex lens, and also its ability to perform in this high lumen density application without yellowing. Next. Another case study highlights the use of MS1003 moldable optical silicone in a UV application. Dow partnered with Philips Lighting to provide a unique solution for UV purification of drinking water. In this application, MS1003 product was used for a lens over the UV light. It also provided a sealing means for the water running through the lens and provides impact protection for the LED device. This one-piece design replaced a traditional multi-part assembly using a quartz lens, thus reducing the number of component parts in the bill of material, as well as simplifying assembly. Next. Our final example is a new development that highlights an all-silicone solution for flexible linear lighting using extrudable optical silicone materials. Benefits include high tensile elongation, flexible lighting design, heat, humidity, UV, and flame resistance, and extrusion and even co-extrusion processes possible, resulting in long light lengths and cost-effective manufacturing. The components include, in the picture in the bottom right from bottom up, a Solastic ES3001 extrudable white reflective high consistency rubber channel extrusion, an LED light strip, an optical encapsulant, and finally on top, an extrudable optically transparent HCR material, which is a brand new development from Dow. This results in a fully sealed linear light with highly uniform light output. So where could this be used? Next. Anywhere long light path, flexible lighting is needed. Automotive and architectural lighting are great examples of how this technology is being used today, where long light paths of clean lighting are needed. The extrudable white reflecting and optically transparent materials make this lighting possible. Next. In conclusion, moldable optical silicones have many unique properties that address challenging lighting opportunities. They have excellent heat resistance, excellent UV resistance, ingress and impact resistance, design flexibility, UL and automotive recognition, and finally, efficient injection molding processing. Next. I tell you, we rushed through this topic today, so for more information, please visit the Dow Moldable Optical website. You can see on the screen at consumer.dow.com/optics. for additional part design examples, product data sheets, and additional case studies. Next. We thank you very much for your interest, and Jake and I hope to answer some of your questions.
Thanks, Tom, for a great presentation. Learning a lot about the Solastic molded silicone applications that you talked about anyway. We're now ready to take questions. As Tom mentioned, I'd like to introduce Jake Steinbrecher, Associate Technical Service and Development Scientist for Dow Silicones, to assist Tom with questions. Again, to submit a question, you can email rpnevents@crane.com, or if you're watching along on LinkedIn, Facebook, or YouTube, submit your questions through those platforms. Here's the first question. Jake, do you want to handle this one? How do the optical silicone materials process differently than standard Lsrs?
Thanks, Joe. So optical silicones are a little bit different from traditional Lsrs in the fact that they're much lower viscosity, and due to that lower viscosity, behave a little bit differently in the metering systems and then injection molding machines as compared to Lsrs. Tom talked about the shear thinning behavior of the material. Moldable optical silicones don't exhibit the shear thinning behavior, but they do exhibit some viscosity thinning due to heat. When this is realized and accounted for, it actually allows for a lower intensity injection molding process because we envision the materials flowing in like water because they're so low viscosity in the moldables. This isn't without some concern, though, as this low viscosity can lead to turbulence and other potential issues. But anyone skilled in the art of molding generally can work past these quite quickly.
Do these process similarly to other materials that can be used in these applications?
Yeah, there are other moldable optical silicones and other types of lower viscosity Lsrs, and they process pretty much the same through what we would consider common equipment across the Lsr industry.
Great. So it doesn't take any additional equipment or any retrofitting or anything else anyway to do this?
Nope.
Super. Can you explain a little more, as Tom mentioned, why the adaptive drive beam part is needed to be made from silicone in Tom's example?
Yeah, so adaptive driving beam is a unique technology in which the lens is extremely close to high power LEDs. So number one, we need a material that can withstand high thermal load. This could either be glass, for example, which is great in thermal performance, or silicones, which also behave very, very well in high thermal load applications. The problem with glass is that it can't be molded or formed into the highly complex shapes that are needed for adaptive driving beam. When we look at the designs, the light guides align to specific LEDs, and they must be extremely close together. And to form a glass piece with that many light guides in that close a proximity is highly difficult, if not impossible.
How do they behave in the UV range, these optical silicones?
So optical silicones are unique in the UV range. Through UVA and UVB, they're actually optically transparent, meaning they either don't absorb or absorb very little. In the UVC range, they absorb somewhat, but still stay relatively transparent through most of that range, with absorption setting in the lower into the UV range we get. And when I say lower, this is below around 250 nanometers. And we have case studies and application bulletins that clearly outline the optical characteristics of our materials at those low UV wavelengths. And
I imagine going to the website, as Tom mentioned, you can find some of those comparisons anyway, how that works in the UV range.
Yep, exactly. And most of the materials for reference behave about the same in terms of aging performance. So.
Great. What's the difference between injection moldable and high consistency rubber lighting materials or lighting materials?
Great question. So we found that our customers were looking for applications in which they could do much longer lengths of silicone lighting applications. In injection molding, you're limited to the size of the platen or the mold tool that's used to make a part. And when we talk about applications in which we're doing LED linear, they can be looking at lengths of meters of material or meters long parts as compared to centimeters long. So a quite big difference. That's very hard to address because you need an incredibly large mold tool. Another way to do this, though, is to use what we call high consistency rubber, which processes through an extrusion line, allowing it to make very long profiles and extruded lengths, which fit these LED linear applications much better. It is important to note that these materials are still in development, but we know that there is a market need, and we're trying to fulfill what our customers want and care about in their applications with a new type of material.
Are you finding generally that that use of LSR instead of some of the injection moldable materials that Tom mentioned in the first slide, that there's some main differences or some advantages, I guess, to the LSR?
Yeah, so moldable optical silicones have a pretty unique advantage in that they are more resilient to UV exposure, thermal exposure, but they also allow for really advanced designs that other optical materials such as PMMA or PC simply can't do. What we look for in applications are the areas where plastics either have difficulty in a design or in an application or simply can't be used. That's where moldable silicones work the best. We never really advocate that they're used as drop-in replacements for plastics because we can do so much more with moldable optical silicones in design.
Can you give a few example or two of where these might be more useful than some of the other injectable applications?
Yeah, one area we see is in what we would consider high power outdoor lighting. So you notice one of the case studies Tom referenced was for a sports light. In these type of applications, we see the lens materials being subjected to the outdoor environment, so high sun loads, high heat loads, depending on the area or geography in which it's used. And then these high brightness LEDs only add to that high heat load. So when we have materials in these applications, they see a combination of potentially detrimental factors, especially when we look at plastics. So we find that those are the types of applications where there's several areas of degradation that could happen, and then silicone fits the role and the need there to kind of mitigate some of the failure concerns. The other thing that we add to that is the ability to do new and unique optical designs. So the ability to control light in different ways or simplify in an assembly, like Tom mentioned, with designing in sealing and gasketing directly into a lens system. Whereas if you used a hard thermoplastic, some of that sealing isn't quite as easy because it doesn't have any compressibility or sealing feature.
I guess one example of the former you mentioned in some of that lighting is the stadium lighting. That seems to be useful for that. You see growth in that area in terms of those kind of applications anyway?
Yep. Yeah, both stadium lighting and then what we consider outdoor lighting, so it's street and area lighting, as well as industrial applications.
Excellent. And I got to clarify, there's no specialized injection mold equipment needed with this, right? Is that correct?
Correct. So we use standard injection molding equipment that's set up for liquid silicone rubbers. That being said, plastics equipment can also be converted to liquid silicone rubber or moldable optical silicone molding. It's simply a difference in how we approach the product, right? In plastics molding, the processing material is at a high temperature and the molds are at a cooler temperature. In silicones, obviously the processing temperature is lower and the mold temperature is higher. To retrofit or convert a machine, we're simply putting a different screw in since it's conveying a different type of material, a liquid, not a solid, and then changing some programming in the machine to look at heating the molds versus cooling them as compared to the processing conditions or processing step, excuse me.
Tom, maybe it's a good question for you. You mentioned LED lighting and the growth of that with some of these optical silicones. Are you seeing this area growing in that respect vis-a-vis other materials, or generally is LED lighting changing, and what's driving some of that? I guess for optical silicones generally.
Sure, the optical silicones, it is a kind of a niche market, but it is growing. We're looking for many more applications to use the optical silicones in. and the flexibility of the process and the product is really gaining a lot of momentum in the optical market.
What's driving some of the growth in that? Is there new vehicles with different lighting requirements part of that, or are there other areas that are driving it?
Sure, even off-road vehicles, the high intensity LED lighting on off-road vehicles, silicone actually is a very good lens material for those. If you're outdoor in the sand dunes, and there's a lot of sunlight, of course, and sand and reduced pitting with the silicone lenses, as well as impact resistance. The silicone does really well in some of those outdoor and automotive applications.
Maybe I'll ask you quickly to quantify. You talked about the next generation Solastic materials, the moldable optical silicones. What are, if you see, what is the really key difference in the next generation compared to what has come, what's now or what's been previous anyway to that?
So I can take this one, Tom. So when we look at the next generation materials, these are the MS4000 series is based directly on customer feedback. The 1000 series, we got feedback from customers that they may have not liked the softness or the surface tackiness of the original materials. So we developed MS4002 with this hard plastic-like surface that's real slick, and in application even feels like a plastic while still maintaining a lot of the unique silicone properties like high thermal resistance and high UV resistance. We also received feedback that in very long path length, or so length of light travel applications, there was some deficiencies in our generation 1 materials, right? When we used them over a few centimeters, there was, or it could be, some detrimental impact to light. So when we developed the 4000 series, specifically 4007, we made sure we addressed the concerns of our customers that they were losing or scattering light in the material, and worked within our chemistry sets to identify the cause of that scatter and develop a solution. So the 4000 series as a whole have a little bit better optical properties for longer path length applications or more precision or more precise applications, as well as have a bit better surface feel and hardness to make them perceive to a user more like plastic.
And those are commercial and available now, those materials?
All 4000 series materials are commercially available, correct.
Excellent. Well, with that, we're about out of time. I thought I'd ask you, Tom and Jake, if you have any final thoughts that you'd like to impart to the audience concerning optical silicones, Solastic materials, anything else, anyway, that you want to mention.
Yeah, I think it's important to remember that, these moldable silicones are unique materials, and they really enable applications and ideas in which plastics and glass and even other traditional liquid silicone rubbers may not work well or at all. They allow for these radically new design concepts and forms, and really need to be considered at the beginning of the design process to take full advantage of all their special characteristics.
Super. With that, we will end the presentation for today. I want to thank again Tom Jenkins of RD Abbott and Jake Steinbrecher of Dow Silicones for taking us through the benefits of Dow's moldable optical silicones. If you have additional questions, please feel free to reach out directly to Tom and Jake, and their contact information is on the screen below their faces there. If you want to email them, they'd be glad to help answer any questions or help with any other information that you might need. Join us tomorrow at 9 a.m. Eastern Time for the start of our full day of sessions at the International Silicone Conference. We'll kick off the conference tomorrow with Kent First of Fredonia Group, who will be updating us on trends and forecasts for the global silicone market. We also have another Ask the Expert live stream at noon Eastern Time Tuesday, tomorrow, with Eric Bishop of Shinetsu presenting on self-adhesive liquid silicone rubber. And we have upcoming Ask the Expert sessions on Wednesday with Hexpol and Thursday with Backer. All these sessions will be available for registered viewers to watch anytime on the Rubber and Plastics News website. That's rubbernews.com. We also want to remind all our attendees that you can make connections through the virtual event platform and schedule meetings and video chats this entire week. I'm Joe Pryweller with Rubber and Plastics News. Stay tuned for a word from our sponsor.